Hello, Year Sevens. This is lesson 2 of our learning journey on all about forces. What we've done is we have looked at forces and what they are and what they do and how to represent them. So we've done this section, that's all done. And today what we're going to do is we are going to concentrate on looking at balanced and unbalanced forces and how we represent them. However, the first thing we need to do is we need to tick off and see whether or not we've got all our answers correct for this first part, forces. So what I'm going to do is I'm just going to show the booklet that you did with the answers on. So if you just give me a second. Here we are. So here's our booklet with our answers. Okay. So if you just pause the video here, you will be able to note and correct yours. And then if you scroll down, once again, you'll be able to note and correct yours if you pause the video now. Now, one or two that I've seen, I've actually got this force here in two places. So if we just copy that and paste it, then we can see another force there. So we can put it like that. It's not actually wrong. Okay. However, they do need to be half the size of this arrow, because that's the total reaction force. So we could have the force acting downwards at either end of the bed, and together those forces acting downwards equal the reaction force of the bed pushing up the person in bed. So again, with this, you might have had some arrows going forward and backwards, that's fine. These are a little bit more tricky. Here, I've done it from the forces exerted from the pin. It's the picture frame is pulling down here, and it's pulling down through that two wires or two bits of string here, and that's creating two forces. And when we add these two forces together, we get this one, the reaction force acting upwards. That reaction force is actually tension in the string. Here, we've got a hook on a slope. We have a normal force acting at 90 degrees. That's a normal force acting at 90 degrees to the actual slope. And we also have friction, which is here, acting against the motion, which would be down this way. Now, we also have the resultant force, which is downwards, okay, which is these two forces added together. Now with this one, we've got lots going on here. The person's leaning against the wall, so the leaning against the wall represented by the blue arrow, and the wall's pushing back with this red arrow. We've also got the person is leaning against the wall and they are squeezing down, so they're compressing, if you like, with their legs. So they're compressing there, and that's creating two forces. One, okay, friction, which is going to go in this direction. Right. And then we've got another force acting upwards here in opposition. And that's where the feet are. And this component here is the result, okay, is a result of these two forces. But don't get too hung up about this. If you've identified this one and this one where the guy's leaning against the wall, that's fine. If you've identified this one going down and friction, again, that's fine. So back to our learning journey then. You have plenty of time to get this down. So if we look back to our learning journey, we can see that we are going to do about balanced and unbalanced forces here. So what I'd like you to do is I would like you to look at your booklet after you've corrected it and read through your booklet from session 2. So go through your booklet. Oh, sorry, you need the answers to these. So still getting the hang of this Zoom and sharing. My transitions aren't very good, are they, year sevens? So, got the wrong slide up. There we are. Yeah. So, if you want to pause the video, and once again, pause the video and look at your arrows and where they are. Thank you. So, moving on then. Okay. So, what I'd like you to do is, first of all, read this section about balanced and unbalanced forces. And then look at these diagrams. I'm going to explain what these diagrams are in a moment. And read this idea about what we call resultant forces, which is the force that acts as a result of our pairs of forces. So what we've got forces. Forces always act in pairs. And when we talk about resultant force, what we do is we look at the result of those pair of forces. What will it do? In this case, we've got two forces acting to the right on this object here. So our resultant force is 5 plus 5, which gives us 10 newtons. So I'll explain what's going on here and some of the maths behind that in a moment. But what you're going to do, first of all, is I would like you to, watch one of the links in this email, this frog assignment, and that email will take you to, that email link will take you to, I'll show you, you've got two videos. One is BBC Bite Size. This will go through the entire unit of forces. It also talks about pressure as well. And this one in particular, this one just talks about balanced and unbalanced forces. Now, once you've done that, what I'd like you to do is come back and attempt these questions. But before you do those, what I'd like you to do is just take on board what we're going to go through now on the visualizer. So, you've been looking at these blocks, okay? And these blocks represent an object, okay? Now what it is if we draw a car, it's going to take us time to draw a car. And then we can put our forces onto the car. And then, but it all starts to get a little bit messy. And also it takes a bit of time to draw our car. So what we do in physics is, rather than represent this as a car and draw it as a car, we represent everything as a box. And that box allows us to then label what it is, the object, what the object is, in this case, a car. So I can then start to put the forces on much more clearly. And it's much easier to see. So what we're talking about when we're talking about balanced forces is we can take any object. If we take any object, because it's any object, we'll just call it object here. And if we place that object on a surface and leave it there, it won't do anything. It'll just stay there. Now, if I want to move this object, I have to apply a force. So if I apply a force here and push this object with a force of, I don't know, 10 newtons, okay, that object will move to the right. As it's sliding across the surface, it will encounter friction between the surface here and the object. So friction is a force that occurs between the surfaces of two solid objects. So we will have friction. And let's say we have friction of 2 newtons. Now, if that friction is less than my push, then that object will continue to move to the right. So now let's just say we take our table and we put some sticky tape on there, some good sticky tape, let's say some Gorilla Tape on there, and it's really sticky. And I put my object on there. And if I push with a force of 10 newtons, then what will happen is, because of the stickiness and the friction, the glue, the bond that's caused between the two surfaces, will push back with 10 newtons. Now, what this means is that the object will stay where it is. And if the forces are the same that are acting on it, we say we have balanced forces. What we actually mean is they're equal. Okay, but we use this idea of balance forces. Likewise, okay, if I take my table and I've got my glue again, my Gorilla Glue on it, and I put my object on there. This time though, I push with 20 newtons, and I throw a bigger arrow there. The Gorilla Glue and the bond between the object and the friction, etc., only generates 10 newtons. So what do you think is going to happen now? Yeah, that's correct. Well, what's going to happen is the object is going to move to the right. That's because the forces are what we call unbalanced. Okay. Now, if we look back to your booklet, what we can see is you're going to need to do some calculations. Now, if the forces are acting in the same direction, we give them a sign. So here we have 5 newtons acting this way and 5 newtons acting this way. So what we're going to do is we're going to say that this is +5 and this is -5. So the actual minus and plus signs of a force tell us the direction. And if it's plus, it's moving in one direction. If it's minus, it's moving in the opposite direction. So we've got +10 -5 here, which gives us a resultant force of, okay, -5 acting to the left. So let's just do one together then. So if we look at this one, we've got 20 and 5. So let's just go back to the visualizer. So there's my block, my surface. I've got 20 acting this way, and I've got 5 acting that way. So I can say that force there is +20 because this is the opposite, this is minus. But what I've now got is I've got a resultant force, that's the result of these two forces, of +20 -5, which gives me 15 newtons to the left. So that's our first example. And if we move on, I'm just going to let you do the second example, and then I'll show you the answer. And then you need to get on and do the rest of this session on your own. So have a go at it, pause the video, Now, coming back to this then. I've drawn it out here. So, now what I'm going to say to keep it easier is if you have the biggest force, always call that plus. It doesn't actually matter, but it just makes it that little bit easier. We've got plus 38 minus 12. So I can say minus 12 plus 38, and that is equal to 26 plus 26. If you're struggling with that, just go to your number line, call it 0. We can say minus 12 here, and then plus 38 will take you all the way to 26 here. So that will give you 26 newtons to the right in this case. Now, once you've watched this video, you should be able to have a crack at these and then start to look at these examples of the cyclist moving forwards or slowing down. Okay, and then move on to do these questions here from 17 right through to 22F. Okay, if you get stuck with them, you can always email me between 10 and 12, Monday, Tuesday, Wednesday, Thursday, Friday. Thank you.